Okay, what we're going to be looking at is how to convert from binary to hexadecimal. Okay, so binary, as we know, the number 1011 is written with a small 2 there to show that this is base 2. A hexadecimal number, such as 12, is written with a small 16. The reason for that is because hexadecimal uses base 16. Hex means 6, decimal means 10. When you add them together, obviously you get 16. So what we need to be able to do is we need to be able to convert from a binary number into a hexadecimal number and then back again. So to do that, what we need to do is, if we start off by working with a byte, which obviously has 8 bits, so if we had the number, or the binary value, sorry, 10011110, what we need to do is make sure that we see them as two separate nibbles. So a nibble is just half a byte. So what we're going to do is we're going to deal with this side first, and then we're going to deal with this side after. So we need to then convert each of these nibbles into a decimal number. So to make it easier and clearer, you can write the base 2 along the top. So we can say we've got an 8 and a 4, which is 12, plus a 2 is 14. So we can write down 14 there. What we've then got is this nibble over here, which there is a 1, a 2, a 4 and an 8, and we've got 1 8 and 1 1, so that equals 9. So we can write that under here. What we then need to do is we need to convert these two separate decimal numbers. Let's write down the superscript number 10. We then need to convert these into their hexadecimal value. Now, when we're talking about hexadecimal, I've said that we store 16 different characters. Now, those characters are 0, 1, 2, 3, 4, 5, 6, all the way up to 9. But then in order for us to be able to store 16, it then uses A to F. And as you can see, there are then 16. The way that converts into a decimal number is for the first 10 values up to 9, including the 0, it's just exactly the same. So 1 is 1, etc., etc. Then when we get to A, that is the equivalent of having 10 all the way up to 15. So our value 14 is E. And while you're revising, you can use the conversion table that you've written in your books. As long as you remember that 9 is 9 and then after that 10 relates to A, you should be able to work out the rest just by counting up on your fingers if necessary. So we know that 9 is exactly the same, so we can just write that there. So what we're saying is that 10011110 in hexadecimal is 9E. Okay, we obviously also need to be able to convert the other way. So we need to be able to convert from a hexadecimal number to a binary number. So if we were given the hexadecimal value A7, what we need to do is deal with them as two separate nibbles again. So we're going to deal with the 7 first. So we need to be able to write the 7 to start with as a decimal number. So the 7 is obviously 7. We know that it goes up to 9 just as numbers. So A represents 10 in decimal. What we can then do is we can convert these numbers into two separate nibbles. So we know that 7, if we're doing it in binary, and again it's always worth writing these across the top, is the, well, we can't have an 8 because that's too big, so we can have a 4, sorry, put a 0 there. You can have a 4, we can have a 2 which takes us up to 6, and a 1 which takes us up to 7. So that's the 7 done. Then we've got the 10. So again we've got the 8, 4, 2 and 1. We can fit an 8 in, but if we now add on a 4 that takes us up to 12, which is too much. We can have a 2 which takes us up to 10, means that we don't need any 1s. So therefore A7 in binary is 1, 1, 0, 1, 0, 1, 1, 1 in binary. Again, you can check that on a conversion table to make sure that it's correct. Okay, if you feel you understand that, feel free to end the video now, but I'm just going to do one more example of both binary to hexadecimal and then hexadecimal back to binary again. So if we had the binary number 1, 1, 1, 1, 0, 0, 1, 0, we need to deal with them in two separate parts. So if we deal with this one first, we first convert it into a decimal. So we have 1, 2, 4 and 8. We've got 1, 2, so we know that that number is 2 in decimal. We then convert this one, so we have 8, 4, 2 and 1, and we've got all of them, so 8 plus 4 is 12, plus 2 is 14, plus another one is 15 in decimal. So we can then convert that into hexadecimal. So 2 we know is going to be 2. 15, we know it only goes up to 15, so that's our highest one. If we look back on this chart up here, and that 15 is equal to F. So we can say that 1, 1, 1, 1, 0, 0, 1, 0 equals F2 in hexadecimal. Okay, one final example then of going from hexadecimal to binary. We'll pick the hexadecimal number of EA. Okay, so we first need to convert both of those into a decimal number using the chart. We know A is 10 in decimal, and we know that E is, well, we know A is 10, so B is 11, C is 12, D is 13, so E must be 14 in decimal. And we can then convert those numbers into binary. So 1, 2, 4 and 8. So we can have 1, 8, can't have any 4s. We can have 1, 2 and no 1s. And for 14 we have 1, 2, 4 and 8. So we can have an 8 and we can have a 4 because that takes us up to 12. We can have a 2, that takes us up to 14, so we don't need any 1s. So therefore we can say that EA in hexadecimal equals 1, 1, 1, 0, 1, 0, 1, 0 in binary.